Chords, arcs, central angles, and inscribed angles. Circles and other related terms. Circle is a set of points on a given plane which is equidistant from a fixed point called center. This circle is called circle O because the center is at point O. Given the circle, the center is at point O, a segment whose endpoints are the center of the circle and a point on the circle, let's say this point is point A, is called radius. A segment that passes through the center of the circle and whose endpoints lie on the circle, let's say this is point B and point C, is called diameter. And this diameter is twice the measure of the radius. A segment whose endpoints both lie on the circle, having point A and point C, this segment form is called chord. Diameter is also an example of a chord. A line that intersects a circle at exactly one point is called tangent line. And this point is called point of tangency. A line that intersects exactly at 2 points, which are point A and point B, is called secant line. And this secant line contains a chord of a circle, which is the line segment AB. An angle formed by any two distinct radii of a circle, so the line segment OA and OB are the radii of this given circle, the angle formed by these is called central angle, angle AOB. An angle whose vertex lies on the circle and whose sides are chords of a circle is called inscribed angle. So from this given, the diameter BC and the chord CG, the angle formed by these is called inscribed angle. Its vertex is found on the circle, which is point C. Semicircle is an arc whose endpoints are the endpoints of a diameter. So the diameter BC has endpoints point B and point C are also the endpoints of the semicircle. So we have semicircle C, A, B. Minor arc is an arc which is less than a semicircle. We have the arc AB. And major arc is an arc which is more than a semicircle. We have arc C, A, G, or C, B, G. Central angles and arcs. Given the circle O with points H, G, I on the circle, angle HOG is a central angle because the vertex of this angle is the center of the circle and the given sides of our angle are the radii of the circle, the radius OH and radius OG. So we have angle HOG. Arc HG and arc HIG are the intercepted arcs. Sum of central angles. The sum of the measures of the central angles of circle with no common interior points is 360 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 is said to be equal to 360 degrees. Arcs of a circle. Given the circle O, the degree measure of a minor arc is the measure of the central angle which intercepts the arc. So angle JOK is equal to the measure of the arc JK. So if angle JOK is 120 degrees, the measure of arc JK is also equal to 120 degrees. The degree measure of a major arc is equal to 360 degrees minus the measure of the minor arc with the same endpoints. So the measure of the arc JLK, which is a major arc, is equal to 360 degrees minus the measure of the arc JK. So the measure of the arc JK is 120 degrees. So we have 360 degrees minus 120 degrees is equal to 240 degrees. Given the circle O, the degree measure of a semicircle is 180 degrees. The semicircle here, we have semicircle JML and the semicircle JKL. So the measure of the arc JML is equal to the measure of the arc JKL, which is equal to 180 degrees. Congruent circles and congruent arcs. Given circle B and circle D, congruent circles are circles with congruent radii. If the line segment AB, which is a radius, is said to be congruent to the line segment CD, which is also a radius, then circle B is congruent to circle D. Congruent circles and congruent arcs. Congruent arcs are the arcs of the same circle or of congruent circles with equal measures. Given circle B, the arc AE is also equal to 45 degrees because its central angle measures 45 degrees, which is congruent to the arc FG because its central angle is also equal to 45 degrees. So if circle B is congruent to circle D, then the arc AE is congruent to arc HC. The same thing with arc FG is congruent to arc HC. Arc addition. The measure of the arc formed by two adjacent arcs is the sum of the measure of the two arcs. So the measure of arc LEV is equal to the measure of arc LE plus the measure of arc EV. Inscribed angles and intercepted arcs. The center of the circle is in the interior of the angle. So the inscribed angle is angle A, B, C, and the center of this circle is in the interior of the inscribed angle. One side of the angle is the diameter of the circle. Angle FDE is an inscribed angle, and one of its sides, the line segment FD, is already a diameter of the circle. The center of the circle is in the exterior of the angle. Angle HGI is an inscribed angle, and the circle or the center of the circle is in the exterior of the angle. The measure of inscribed angle is equal to 1/2 of its intercepted arc. Angle PHE is an inscribed angle, and its intercepted arc is the arc PE. If the measure of angle POE, which is a central angle, is equal to arc PE, which is equal to 45 degrees, the measure of the inscribed angle PHE is equal to 1/2 the measure of its intercepted arc PE. So we have 1/2 times 45 degrees is equal to 22.5 degrees.